Hi, this is Jeff Coronado on behalf of JCSE, and this is a session in Bridging the Gap. If you're not familiar with our sessions of Bridging the Gap, I invite you to take a look at the introduction, the JCSE LLC channel introduction, and that'll give you a better feel for what we're about, what we do in these sessions. But with that said, I'm just going to jump into our session here that we're covering right now. And what we've got is a session in WPF7A. This is, I believe this is the second session. So it's for mechanical equipment platforms. And in particular, what we're covering here are corner weights. Okay, so what are corner weights? So here we have a fairly standard looking air handler on a rooftop, right? Unit like this. All right. And let's just say you're a structural engineer and you need to support this equipment, right? You need to provide the framing down here, the meat, to kind of support this unit so that this thing doesn't just kind of come crashing down through the roof. I think a valid question would be, well, how much does this thing weigh, right? Seems like we would need to know how much it weighs if we're going to provide a support for it and make sure that it doesn't come crashing through the roof. So it seems like a logical place to go if you want to find out the weight of the air handler is to go to the manufacturer, right? Ask them, how much does the thing weigh? Okay, so here's where bridging the gap starts to kick in for you. So be aware, there are typically two weights that are used in describing an air handler. One is a dry weight or a shipping weight. The other one is an operating weight. So I think as the names might imply, if you hear them, the dry weight or shipping weight is how much the unit weighs when it's being shipped to the site. Now, is that what we're interested in? Think about it. So if we're going to provide support for that unit, no, the answer is no. We're not interested in the shipping weight. We are interested in the operating weight, okay? And why is there a difference? Well, because this unit, once it's operating, there are fluids in there, right? There could be water, there could be freon, there's fluids in there. So the dry weight or shipping weight is different than the operating weight. Now, once we know that operating weight, are we done? Is that all we need to know? No, the answer is no. And why is that? Okay, because we got to get back into center of mass. Remember good old center of mass? So if we look at, let's say we call this kind of the longitudinal axis of the unit, okay? And so I'm showing that in black. In red, I'm going to show the transverse axis of the unit. Let me see here, use black. So be aware in this area here, this is a fan. This is a fan. So it is much lighter. It's a lighter part of the air handler, which means that the compressor, the engine, the motor of this thing is back in this area. Okay, so the center of mass in the longitudinal direction is probably going to be somewhere in this area. Okay, in the transverse direction, yeah, it'll probably be closer to the middle, but no guarantee of that, right? The point is no guarantee on where the center of mass is going to be of the unit, but what is almost guaranteed is it's not going to be in the middle of the unit. So if this unit weighs 100 pounds, it would not be a fair assumption for you to say, well, 25 pounds are sitting in this corner, 25 pounds in this corner, 25 on this corner, and 25 in the corner that we can't see. The center of mass does not coincide with the center of geometry. So if we don't support the air handler based on the operating weight, then what? Well, that's where the corner weights come in. So as your intuition might be telling you, the corner weight is the weight at each corner of the air handler, and those corner weights are based on center of mass. How do we obtain the corner weights? Well, we request cut sheets from the specific air handler for that specific air handler from the manufacturer. Those will show the four corner weights for the air handler. Okay, so that's a pretty key term to know in industry is the cut sheets. When we talk about cut sheets, this is the kind of information that we expect to get in the cut sheets. Okay, so if we have the cut sheets, then we'll know what each corner, the load that each corner needs to transfer to its supporting structure. So that way we know if we've got, let's say, a beam running underneath this corner here, right? And we know that the corner weight is well, probably what we don't know. Here's another thing for you to understand, especially in a design situation. We do not know how the air handler is going to be oriented, right? In this case, you can see in this illustration, the fan is on the left side, which means the compressor is on the right side. But the reality is when we're designing this structure, we don't know if they're going to put a fan on the left side or fan on the right side. We can't specify that. So what do we need to do? We need to envelope the solution, right? We need to assume that each beam that's supporting this air handler, and so let's say there's another beam going underneath this corner, all right, we need to assume that each beam is going to be exposed to that heaviest corner weight that we've got. Usually then when we're doing supports for air handlers, we have to kind of envelope the solution. We have to look at the air handler possibly being in a couple of different situations so that we're covered in these for design purposes. All right, now, are cut sheets always available to know the corner weights? Well, no, the answer is no. Sometimes the best that we can do is work with an operating weight. And then if we know the operating weight, we have to make some assumptions. So we kind of have to assume where that center of mass is going to be. Again, we know, the one thing we know is that the center of mass is not going to coincide with the center of geometry. Okay, but the question then becomes, how far will the center of mass be from the center of geometry? All right, so right now what we're looking at is, let's say, right here. Okay, so the most reasonable, but not the most conservative assumption is a 1/3, 2/3 split. Okay, so we can assume that the center of mass is 2/3 of the way over from the end of the unit. So in an example, let's say we look at a 100-pound operating weight unit, we're going to assume that the corner weights are 33 pounds at each of the heavier corners and 17 pounds at the lighter corner. So the total of that is 100 pounds, but you'll notice we're not assuming 25 pounds at each corner. We're assuming that 2/3 of the unit, 2/3 of the weight of the unit will be on one side and 1/3 of the weight of the unit on the other side. And then that's equally distributed between the two corners. Now, a more conservative assumption, which is still within the realm of a reasonable assumption, is a 1/4, 3/4 split. Okay, so if we take a 1/4, 3/4 split, in other words, 75, the center of mass is 75% off of the edge of the unit for a 100-pound operating weight, then we're going to assume corner weights of 38 pounds and 38 pounds for the heavy side and 13 and 13 for the other side. 3/4 of the weight of the unit on one side, 1/4 of the weight of the unit on the other side. Those would be reasonable assumptions that we need to make if we don't know the specific corner weights for a rooftop air handler. Okay, so let's clear the screen there. Let's see if we can move on to our next screen. And actually that concludes this session of Bridging the Gap. So yeah, uh, take a look on our channel for other WPF7A sessions that will deal with other aspects of the mechanical equipment platform, everything from sizing elements and connections to the actual assembly itself. But this is the session regarding corner weights. All right, and what are corner weights? How do we use them? All right, if this was helpful to you, sure would appreciate a thumbs up. Sure would invite you to subscribe to the JCSE LLC channel. Just hover over the JCSE logo and click on subscribe. And I believe there you can toggle so that you receive notifications of when new Bridging the Gap sessions are uploaded. Okay, real good, guys.